We all of you welcome you.
Formal welcome, don't minute. So formal welcome.
Hello, Chaudhary sir.
Hello.
Hello.
Hello. Oh, yes. Give me 1 minute.
Hello, Chaudhary sir. May I audible?
Yes, yes.
Okay. Welcome, sir. Ghare sir will looking after this session.
Okay.
First of all, I will congratulate you for receiving the award.
Thank you, sir.
Okay, sir. I will hand over to Ghare sir so as we can have a session. Thank you. Okay. I am Dr. Nikhil Ghare. I am working as assistant professor in chemical department. So we will just start your session. Here I will first introduce you. Sir, Dr. Nitin Chaudhary is associate professor in the Department of Science, School of Technology at Pandit Dindayal Energy University, PDEU, Gandhinagar, Gujarat, India. Dr. Nitin has received his PhD degree in material science from Korea University, Seoul, South Korea in 2013 under the prestigious Korean government's fellowship. After PhD, he subsequently worked as research professor at Myeongji University and then at Korea University, South Korea between 2013 and 2019. Before joining PDPU, he was deputy director at Nexcoms Limited Company, Daejeon, South Korea. He has over 35 peer-reviewed paper publications in reputed international journals with over 2040 citations. Dr. Chaudhary is also acting as a reviewer to the papers submitted to various journals and expert reviewer to evaluate the project research proposals submitted under various schemes. Currently, his group is working on various fields on material chemistry, nanomaterials, and catalysis. And he has international project funded by DST under the Indo-Korea bilateral cooperation. Dr. Chaudhary is life member of Korean Chemical Society, Royal Chemical Society, Material Research Society of India, and selected as young associate by Maharashtra Academy of Sciences for the year 2020-21. So now we request Dr. Nitin Chaudhary sir to start his session.
Thank you, Dr. Nikhil Ghare. Can I share the screen?
Hello, share kar.
No, it's not possible.
Yes, sir. Yes. It is shared, sir. Just.
It's visible now.
Yes, sir. It is visible.
Okay, good afternoon, and thank you, Dr. Nikhil Ghare, for the introduction. I would like to add one more sentence there. Basically, I'm also from Jalgaon. I did my schooling and college, did my BSc, MSc from MJ College. And then I moved to Pune, and I was working in NCL as a project student. And from there, I got a chance to go to South Korea to do my PhD. I would like to thank Dr. Hussain, Dr. Diware, and all organizing committee of the International Conference on Global Trend in Science, Technology, Humanity, Commerce, and Management. When I saw the title, I thought maybe I should not present specifically in nanomaterials, completely deep in the nanomaterial. Instead, what I did is we'll take you to the two energy crisis topic. One is fuel cell, and another is the hydrogen production. Yeah. So briefly, I will give you one example of how the fuel cell technology can be used, and In the second part, in the electrochemical hydrogen production, I will present or I will give a very short idea what we are working now. Okay, and what my group here at Pandit Dindayal Energy University is doing. I thank you, Dr. Nikhil, for a detailed and nice introduction. Okay, so before I go to the what is fuel cell technology, I will take you one example, and later on I will come back again to the first fuel cell technology and how this is used or is being used now. First of all, what is aviation? Aviation, all of you know, is related to the aircraft, and there are many different types of aircraft, from balloon to the missile guided helicopter, aeroplanes. These are all the types. But the one which is fastly developing is the unmanned aerial vehicle, which is UAV. Okay, we simply call them as a drone. And why the technical name UAV? Because we don't need a pilot, and those that can be controlled from the ground, or a pre-planned course is fitted by the help of ground control system. So the drone will do its activities or the missions can be carried out according to their pre-planned activity. So that's called the UAV, unarmed vehicles. Okay, and it's a drone. So how the fuel cell technology can be used or is being used in these drones. That is what I will do in the first half, and in the second half, the hydrogen production using the electrochemical catalyst reaction, water from hydrogen production from the water. Okay, so why unmanned aerial vehicle? That is drone. The thing is because the very important for
कनेक्टिविटी के लिए
बोला नहीं त्यांच्या
hello. Hello, there is some connectivity issue, sir. Can you hear me? Hello? Hello? Nitin Chaudhary, sir, can you hear me? Hello?
प्रॉब्लेम आला
Huh?
सगळेच जण झाले तुम्ही पण लेट झाले म्हणून तर मी तिला काय आता
There is some technical issue. So you be online. As soon as we get the connectivity, we will start. So you don't leave the meeting. Be online.
Hello, am I audible now?
Hello.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Oh, sorry, it was went. I don't know what is the problem. So where I was the last time when.
Okay.
The second slide, I think you're in the second slide. That drone slide. You're.
Okay, this one.
Yes, yes, yes.
Okay, I will go to.
Yes, sir.
Okay, thank you for letting me know that it was. Is it visible now?
Yes, sir.
Okay, so I think do I have to go through this or it was? Okay, so the importance of UAV and unmanned aerial vehicle, that was I was explaining, and I'm sorry for the interruption. It's been very common from last 2 years because of the online conferences. Okay, why UAV? Is if you look at the tactical or the high risk mission, this is without human. So the chances of losing the human are very highly trained, skilled pilots with wellness. These are cheaper than aircraft. So, and the flights are predefined or controlled by computer or ground control system. So you can easily control the path and also can be predefined mission, and that can be controlled remotely from the ground control station and does not need runway or takeoff. That can virtually it can vertically it can be take off or landing. So you don't need a very big field or specific runways for the drone. And specifically, these are designed for high risk missions where the surveillance, security, national security is very important. And these drones can be fitted with high resolution camera. We call them as a payload. So if you fit it with a high resolution camera, it can send you the clear pictures of the or the missions. I will show you the many other applications of these drones. Okay, so if you look at how the interest started with UAVs, or the first practical mission was started in 1967 or 70 during the war of attrition between Israel, Egypt, and Jordan. Because during the First and Second World War, many countries who were participated in those wars, mostly the Second World War, lost their aeroplanes, the fighter planes, as well as the human casualty, the pilots, the trained pilots, skilled pilots. So the major from the Israel, the Shabdi Bril, brought this idea, and that he can be credited as the inventor of the tactical UAV to use UAV for the national security or during the purpose of war. Okay, so if you compare now the key points of drone, I will take you that why the fuel cell technology is being used in a drone. This is what the answer is. Usually, when you run these drones, they fly on the battery. Okay, when you have batteries, the average flight time is 20 to 25 minutes. That means these drones in a tactical mission for their specific action can have a very limited time to complete that action from takeoff to landing. So if you go for this very well-known drones, you can see the flight time is average between 20 to 25 minutes, and the control range is from 200 to 2000 meters. What does it mean? From the ground station, you can control this drone up to this distance or height. Okay, and these are the fitted with different cameras. So the flight time is very limited, 20 to 25 minutes. If you increase the drone, that means if you have very high resolution cameras, the flight time will decrease. That's called the payload. Now, what happens after every 20 to 20 minutes, the drone have to ground it and change the battery. And again, it will go to the mission. Okay. But there are only two options: to carry many spare batteries or have a battery charging station at destination. So when the drones are grounded, we take out the discharge battery, charge it at the battery station. It will take a long time, then fit it again. Or the other option is to carry a many fully charged battery, independent upon use also. If the use is only for taking pictures, the time doesn't matter. But if you are covering some event or going for some mission, the time is important. In that time, in that case, you don't want to use the time of battery change and taking out the battery and charging. Okay, and another very important message, just like I mentioned in the earlier slide, is unmanned. Means the waste is less, so you can use that less waste to carry up something else as a payload. Okay, and just like a fighter plane, you don't need a life support system because these are unmanned aerial vehicles. Okay, so when I say battery change or battery charging station, and if you are using the drone for high resolution camera, look at if you are covering a live match. The live match will not stop for the drone to get grounded and change the battery, but it will continue. So for this application, such application, use of drones is very limited. Okay, recently, a few years back, FIFA tried to deliver the soccer ball at the ground field using the drones. That was the start to see how the drones can be used for a major international event. So this is the one example. Another example is, yeah, if you have a cricket matches going on, can we replace that drone? Spider cams using drones? The answer is no, because as you know, the cricket match goes for many hours. Battery cannot last that much. Carrying the very huge high resolution camera. Okay, the another examples of the drones where people are using in the medical health, in emergency medical health, because of the traffic congestion, healthcare system is more dependent on the drones who can easily provide the medical help. The food delivery, Amazon is already in the market to deliver the parcels on their products door to door using the drones. In agriculture, consider the field which will take a whole day to spray the pesticides. The drones can do it that in a few minutes only. Okay, the another in is life safety guards. They can easily carry the tubes and drop where they are needed. Okay, one of the major tactical mission is provide the ground support to the front line soldiers. Okay, here the chances drones is without human pilot, the chances of getting cut or destroyed is less casualty. And one more is to the extreme left. One of the very important application of drone is in the point of environmental issue. Like the drones can be fitted with some gas collecting apparatus, and they can fly over the industrial area easily, go very near to the chimneys, and can record, can measure which toxic gas is coming out or what are their concentration. They can collect that samples, and then they can send the live real-time feedback to the ground station about the concentration. Another one is the police. During the last 2 years, not just in India but everywhere, police use drones to keep eye on the crowded places or the social distancing. The another one is the as a fire extinguisher. You can fit it with the fire extinguisher. You can send it to the jungles or forests, and that can be easily controlled. Okay, so these are the very major application of drone. So if you go for just taking a picture, and is it moving? Sorry, there is some problem. The network. Give me a minute. Sorry, there seems to be some problem on the computer. Okay, so if you look at only for picture and photography, the time is 20 minutes. Small drone is okay, but for this kind of application, you need a huge drone. Huge drone in sense that should lift, carry the payload in kgs, 20 kg, 30 kg, 40 kg. In that case, the battery doesn't work. So what is the alternate? So there is one more example. Quickly, I will give you. Recently, India also used the drones to deliver vaccine, COVID vaccine, which covered up to 30 kilometers of area just in 15 minutes. Usually it takes 3 to 4 hours if you go by ground. So the importance of having drones is very important. There is a video here, but I will skip it because I'm having some issue maybe because of the video. Okay, so there is an example of this again. If you have a drone weight 2 kg, the flight duration 30 minutes, the battery costs $185. The charging station like this one costs $110 USD. The maximum power is 165, and the battery weighs around half a kg. Okay, and the pure purpose is photography, but this type of drones cannot be used here. Okay, so how can we increase the flight time and the payload? What are the alternatives to the battery? Because battery's weight is very important. Most of the weight what the drones are carrying is because of the battery, almost 30 to 40%. And also the safety, environmental issue. The answer is fuel cell. Okay. So briefly, I will tell you how the fuel cell can be used, but what are the challenges there? Okay, and how research is going on. I had some work in this field earlier before joining PDQ. That's why I would like to show this one, and the later one, the work which we are doing now. So why fuel cell can be used? Just take one example. If you are having an aeroplane which needs 25 kilowatt power at 160 kilometer per hour, and the flight mission is 500 kilometer, it needs 75 kilowatt per hour energy power. Okay, if you want to generate this much, if you use the lead acid battery, the weight is 3,000 kg, and nickel based 1,500 kg, lithium based 100 kg. If you use the fuel gasoline, although it is only 100 kg, but we are depleting and the price are getting higher. So people are trying to go to the non-renewable sources. So instead, if you use the fuel cell and also equipped with the hydrogen tank, the weight is only 165 kg. That's what the one I was trying to explain, that battery's weight is also very important when you talk about the UAV or the drone, the tactical drone. So if you decrease that weight from, for example, 3,000 or 1,000 kg to 165 kg, you can use that extra weight to carry out your mission, to transport, for example, for delivery, or in the if you are using it at the national security border, you can carry the human missions or the life support to those frontline soldiers. So this is why the fuel cell is very important. The another technical reasons are quiet, does not make any sound, so it can be stay very quiet. Only the propeller noise, the wings, no emission, no pollution, environmental friendly, no waste, only water. If you use the fuel cell, improved life cycle, you can use that repeatedly for many missions. Easy maintenance, you don't need to take out the battery and charge it again as long as you have the fuel provided. Okay, and also high energy density and safety is also comparatively higher. Okay, so why fuel cell and not the battery or capacitor? If you take out the example of 100-meter versus 1000-meter race, uh, what is power density and energy density? Mostly the students should understand this. Many students make the misunderstanding of the power density and energy density and where to use supercapacitor, where to use batteries, where to use fuel. Just take one example. Now, if you are running a 100-meter race, what you need is a power at a very quick power, so that you get finished. You go to the finish line. So that tells you the power density, tells you how fast you can run. Okay, and energy density tells you how far you can go. So if you are using, if your application is for a very long period of time, you go to the fuel cell. It gives you the constant source of energy. Okay, for example, 10,000 meters. The 10,000 meter athletes do not use all the energy power in the beginning because they have to maintain it for a very long time. Instead, supercapacitor are used where the power is needed for a very short time. Okay, so that's the power density versus energy density. So fuel cell gives you the higher energy density for a very long period of application. So now coming back to the main topic, what is fuel cell? So what are the types of fuel cell? There are alkaline fuel cell, protonic fuel cell, direct methanol fuel cell, phosphoric acid, molten, and solid oxide. So there are many different kind of fuel cells. They are depending on the names come from mostly the electrolytes. They have the different operating temperature, efficiency, and different mixtures. Okay, so if you go to the aviation, if you are using this fuel cell technology for drones or UAV, last three phosphoric, molten, and solid used because of the very high operating temperature. Then comes to the alkaline, proton exchange, or direct methanol. Direct methanol fuel cell, you have to carry the methanol. Storage of methanol is also one issue. Then proton exchange membrane fuel cell, where you have to have the fuel of hydrogen at the one side, and the another side is oxygen or air is filled. Now, to consider the weight, you want to decrease the main research for this type of application is how you can decrease the weight so that you can use the more payload, and how you get the more power or the efficient fuel cell so that it can be used for a very long mission. So instead of using two cylinders, hydrogen and oxygen, for this kind of applications, the air is used from where you get oxygen. Okay, and only the hydrogen tank is provided, fitted on the drone. I will show you now that. So this is the proton exchange membrane, or we can say now fuels. Okay, so at anode the hydrogen gas is fitted, and at the cathode mostly the pure oxygen or oxygen from the air. For this kind of application, we will use the oxygen from air only. So along with fuel cell system, you have to carry the hydrogen fuel, okay, the tank, and that will provide you the hydrogen gas. So that hydrogen gas is split into the plus and electrons, and this ion goes to the proton exchange membrane, then meets to the cathode, and you get the energy. And what are the side products? Only water. Okay. So if you use this fuel cell at the ground station for the application, for example, in the vehicles or the power stations, you can easily recycle this hydrogen. But at in the air, in aviation, you cannot use this hydrogen recycle. You have to utilize whatever hydrogen you have. It's like sending a person in a space with limited oxygen and asking to stay alive with that oxygen. So this is the same thing that happens here. You have a very limited hydrogen, so you have to utilize that. So the research is going on how to use that, how to decrease that weight also, how to get the maximum oxygen from the air instead of providing the fully oxygen loaded cylinder. Okay, so this is the single cell, and as you know, the single cell does not is not enough for you to power or run the fuel cell. So we put it them in a stack in the series, and depending upon how much power you need it, you can increase or decrease the single cells in the fuel cell stack. Okay, so what we do here in aviation, we get a very limited hydrogen from this tank, and instead of recycling it, we block it. The other end is blocked. So whatever the hydrogen is there, it's being utilized. But in this case, the pressure, the hydrogen feeding is very important because it should not break the catalyst layer, the gas diffusion layer, the proton exchange membrane. And if you are the listener or the audience is from the nanomaterials or working in a fuel cell technology, they are aware with this situation that the hydrogen should not cross over. Okay, it should not meet the oxygen. Okay, so the chances, if you increase the pressure, if you feed more hydrogen, it will break the catalyst layer, proton exchange membrane, and it meets the oxygen. And when it meets the oxygen, it can blow up all your system, the explosives. Okay, so to keep the pressure very uniform and as low as possible, and use the maximum hydrogen from here. And the oxygen is being sucked out from the air. Okay, and this is how we use the limited hydrogen. And this is the example of the drone I am showing from the IntelliJ, very famous and well-established system they have developed. The hydrogen tank is fitted, and here down you see the black color is the fuel cell stack. This one, fuel cell stack, is fitted here, and the hydrogen is provided here. And from the back side, there are fans that can intake the oxygen from the air. Okay, so we block it by one end, but there are advantages like fuel utilization. You are using the fuel as much as possible, so you decrease the weight. Okay, so if you decrease the weight, you can use maximum payload. But there are disadvantages. It gets accumulated here. Okay, and the deactivated regions are formed here. So that means whatever the hydrogen is coming is have only less than 50% area to the catalyst or for the utilization. That they are forming a blanket here. So that means not enough hydrogen is coming in contact with the catalyst. So we are losing the efficiency. Although we are trying to reduce the weight and use the little fuel, but what we came up with this, the scientists, they put a wall there. So after every 10 or 15 seconds, the wall will release for very few seconds and will take the unnecessary gases or whatever the vapor or anything formed there, it will be thrown out here. So again, all these deactivated region will be open for hydrogen. So this is for the anode side. The another side is your the air. Now you are feeding the air. It's not pure oxygen. So what happens most of the time? The nitrogen gets accumulated there. When the nitrogen gets accumulated, means again it is blocking the oxygen which is going in contact with the cathode side catalyst material. So in that case also the efficiency decreases. Okay, and also the side product of the fuel cell reaction is the water. That water vapor also gets accumulated on the cathode, decreasing the efficiency. So these are the disadvantages. While they have advantage of fuel utilization, weight reduction, but the disadvantage of nitrogen accumulation, water accumulation, and fuel starvation. Fuel starvation means not enough fuel, hydrogen or oxygen is reaching to the active catalyst material. Okay, and the solution came up with the continuous purging, but in that case also most of the hydrogen is being thrown out. Okay, so this is how fuel cell, when you go through all these assemblies, this is how it looks. These are the fans which will bring the air inside. It will push the air to the cathode side. The hydrogen gas, the tank will provide hydrogen to the anode. So here is this. When you start the fuel cell system, the fan will suck the air from outside. Okay, the air will be provided from here. Hydrogen will be provided here, and these are the hydrogen out, in and out. Okay, and there are many different channel-like structures being developed for the maximum fuel utilization. So if you go here, this example, this not just the water is the side product, but it generates heat also. So when you are considering about the fuel cell technology, the one important thing at the cathode side is you should keep the temperature as below as possible. So not just this air works as a oxygen gas to the cathode, but this the air also cool down the cathode side. Okay, and there is one more research is going on in the fuel cell technology. When you develop this kind of channels, then they should not be straight. In that case, what will happen? The air will be quickly go out. Okay, whatever the air is coming to the fan, it will go quickly. So people are trying to develop a different kind of patterns of that channel, so that the air or the oxygen will stay for a very long time. The longer time it will stay, it will be in more contact with the catalyst material. So people are trying to develop different channel length, width, diameter, depth, zigzag, some the different patterns of the inlet and outlet channel width. So the research is going on how to the ultimate aim is how to use the maximum fuel in the air, not just hydrogen but also air. Okay, and the more the cooler air will stay there, it will decrease the fuel cell temperature and it will give you a more efficiency. If the temperature increases for this side, the chances are very high it breaks the catalyst membrane. Okay, and the roar and tour, and in that situation, the hydrogen or oxygen get crossovers. Okay, so there are many different challenges still not being completely solved, and so still the research is going on. So this is the one, the fuel cell. If you put it on the drone, this is how it looks. Okay, so now if you come back again, how we work, not just the catalyst, but I work in a various field of developing the cathode plates, the bipolar plates, the design, the fan, the fuel and air. So another thing is, now if you look at this, the complete system, the 50% is stack, means this one, the cost is 50%. Now if you go to the single cell, almost 51% is the electron. That means the catalyst and anode. It costs 51% of the cost. And then the bipolar plates, because of the metals, gas diffusion layer, and sealing, balance tape, assembly, machining membrane. There are many different parts of the fuel cell. Now, the 51% electrode, why? Because mostly the noble metal are platinum. Okay? And that increases the cost of it. Platinum is highly active for these reactions. Okay, so how we can decrease the cost of this, and then the final cost of the drone or the fuel cell technology. Although it is a good efficiency, no pollution, no noise, but the cost is the main problem. Also the durability. If you, the platinum shows very good cycle stability and long-term use, but the cost is increased. Okay, also the other region is another area to think about the hydrogen storage. Okay, we cannot stay for a very long time on a tank only. People are trying to develop materials that can store hydrogen also, that can be used. For example, if in my later talk I have, if you produce the hydrogen, you can store it, and when you store that hydrogen, you can use it. Okay, because the production of hydrogen, transport of hydrogen, and storage of hydrogen is also very critical issue. Okay, how we can decrease the cost? By alloy formation. For example, platinum nickel, platinum Fe, platinum cobalt, and if you, in this case, you can decrease the platinum, use of platinum to 50%. If you use the trinary, quaternary, earth abundant material, you can even more decrease the cost. But somehow you have to sacrifice the efficiency, or this material are not that much active as compared to the platinum. Okay, what we did is we developed many different materials because of we have 1 hour. I will quickly show you only one example, which how we help or develop the material. Okay, so the development of low cost carbon support is the one area. The another is the alloy formation, forming a different platinum or catalyst material composite materials. And what are those low materials? Transition metal oxides, sulfides, phosphides. Can they replace the platinum? Okay. So if you look at the catalyst here, the catalyst layer, you will see mostly the carbon, highly porous carbon materials are used there, and the platinum, small nanoparticles are deposited on that catalyst support. And this platinum works as an active material for the anode reaction, where the hydrogen is split into the H plus and so electrons, and oxygen, carbon gives the support so that the maximum platinum can be deposited, and that can be used for this reaction. Okay, so the synthesis of carbon material is a very lengthy process. First, you prepare the silica, and then you fill the polymer sources, and carbonize it, and then remove the silica or the whatever the template material. We say this is template method. First, you have to synthesize the template, fill the carbon, and carbonize it. It means heat it at a higher temperature and remove the template material, which is silica. Then you get the highly porous carbon material, and then next step you deposit the platinum catalyst on that. So this is very lengthy and long process. What there is another method is here, the synthesis of hollow core mesopocial carbon. From this group, they prepare the silica, use the different polymers and calcinine, then again remove the silica material, and they get the various carbon material that can be used as a support. Okay, so this is from this platinum and support, these two different areas to work. Carbon can also be used for the support. Okay, and that carbon material should have very high surface area, enough pores. The synthesis route should be low cost, simple, environment friendly, and cost effective. Should have very high conductivity, and from last few years, people are also trying to dock different heteroatoms to increase the electroconductivity and as well as the efficiency of that catalyst material. So in last 10 years, some people have tried to synthesize the carbon instead of using the traditional well-established commercial method. People have tried to find out is there any cheap, low cost, but highly active carbon material can be synthesized. And if you go to the literature, you will find people have burned each and everything from biomasses and waste carbon, whatever the waste they receive, they burn it and try to synthesize the carbon material from corn, shell, cow dung, fish shells, the seeds, wet food, or hair, and leftover leaves, and the daily carbon use, paper waste also. But what was the problem with this? This you have to go through various multi-step process. Okay, and these are mostly, for example, the coconut shell is very highly rigid. You need an activation. You need to break it. It's very hard. You need to break it, so it will increase the pore structure, surface area. And the activation method is mostly carried out at high temperature using KOH, CO2, or zinc chloride. And also you have to put the pore generating agent. I wish I had the more time, or another time I will give more thing on what are the pore, how the surface area is important, how to increase it, what are the pore sizes are good, and all those. Okay, and then externally dop the material. Okay, externally use different nitrogen, sulfur, or phosphorus type materials to bring it in the carbon to increase its conductivity, electrical conductivity, and stability also. So these are the 4 different methods. What we did it a few years back, we simply used the human urine and we converted it into carbon, and we tried to use this carbon material for this kind of application, not just the fuel cell, but battery and capacitor. In this case, we avoided mostly all these steps. And when you synthesize the carbon from the waste material, this was one of the pioneering methods we developed. What we did, we collected urine, we just simply allow it to dry and carbonize it, and wash it, we use the carbon. We don't need a multiple step, you don't need the activation at higher temperature, you don't need to pore generating agent, addition of pore generating agents to make it highly surface area, and also no external doping was needed. Okay, but why we use the urine? Because one of the most abundant on planet, 7 billion people produce around 10 billion liters of urine in a day. Okay, easily collected, and environmental benefits seen as a vital carbon source rather than a waste. Instead of throwing it, use it. Very fewer pollutants from urine to the water bodies to the groundwater. Very cost effective and no side product. Can reduce the burden of disposal of human waste. So when we carbonize it and simply wash it using acid, we got the carbon material. Okay, and that carbon was highly porous material. If you see, you can see many different pores like structure from these TM images comparatively to the one we synthesized without washing. And we studied in detail the different carbonization temperature effect, the washing effect, and we did a more detailed study on this. And this if you go to the physical characteristic, the surface area was 1,436. Very high surface area was achieved with a very constant pore size. And we had a various detailed study on the different. Okay, am I audible?
Yes, sir. Yes, sir.
Wait. Just give me a minute. My PowerPoint is hang. Okay, sorry. Okay, we cannot build the technology. Okay, so we had a detailed study and different temperature, and we also studied that the urine contains different heteroatoms, like for example nitrogen, sulfur, silicon, phosphorus, that help to enhance their activity, and we do not have to externally drop it. Okay? We utilize this carbon, and that work was well acknowledged all over the world, from discovery to Asian scientists to genius and science magazine. Everywhere the people were or the scientist body knowledge that this can be another source for the fuel cell material using human urine. Okay, a lot of work is still be going on. We are trying to improve quality as well as the application of this carbon material. Okay, and that was also highlighted in Jalgaon newspaper at the time. Okay, and beside this, quickly I will give you some more example. We are not just working on carbon, but we are trying to replace the platinum. So we have synthesized the nickel cobalt oxide, nickel sulfide, core shell material, lateralite material, hollow material, FeNi. We also try to deposit PT here, so PT, FeNi, cobalt sulfate, and hollow cobalt sulfate. So these are the very few examples how instead of using expensive rare earth noble metal, earth abundant transition metal oxide or phosphide or sulfide can be also used for this one. Now the another part is the water splitting, hydrogen products. Now it has been estimated that global energy consumption will increase to 13.5 terawatt in next 40 years. And what are the major sources of energy? Non-renewable. Mostly we are using on coal, gas, the oil, and the gas oil. And people are going to the renewable sources to use, for example, the solar cells, the wind, and the water. Okay, because of the very limited sources, the non-renewable, we are quickly depleting. We are going out. The sources are going out. Now, why to split the water? Because water is a simple chemical molecule made of two molecules of hydrogen and one oxygen. Okay, if you split it, you can generate the hydrogen and oxygen, but it's not that easy. And why to split? Because 70% of Earth is made of water, abundantly available. Hydrogen fuel production has gained increased attention. Oil and non-renewable fuels are depleting and becoming more expensive day by day. But the problem is now, what are the current global hydrogen production? Still, the 48% comes from natural gas, 38% comes from oil, 18% comes from the traditional coal, and only 4% from the electrolysis of water. And many governments and funding agencies are trying to encourage scientists and research to go to the research for the hydrogen production, on storage, on the water splitting, may it be electrochemical or photoelectric. As in the introduction, Dr. Nikhil mentioned, we have an international project from India, Korea, from the DST, from Indian side and from Korean side. We are working on this, the electrolysis of water, to split it electrochemically and for the hydrogen production and storage. Okay. So what are the methods? Electrolysis, photoelectrochemical, photocatalytic, radiolysis, biological, thermal, and nuclear and chemical production. There are many different water splitting methods are available. So if you pass an electrical current to the water between electrodes, the positive minus force of battery, the water will split into oxygen and hydrogen. So traditionally, the steam formation, you provide the methyl and oxygen, it uses the hydrogen, but the problem is the carbon and carbon dioxide, carbon monoxide, and the another one is the electricity, it produces the hydrogen and oxygen. So these are the things how the water splits into the hydrogen and oxygen. But if you come to the electrochemical water splitting, here there are two reactions are involved. One is the hydrogen evolution reaction, the another is the oxygen evolution reaction. Now, similar to the fuel cell, here also the problem is the highly expensive precious metals. Platinum, rhodium, and ruthenium are usually used for the hydrogen to the cathode side. And if you talk about the anode side, in the oxygen evolution reaction, again the iridium, ruthenium, or their oxides are being used. Okay, so what happens at the OER, for example, this precious metal or their oxides split the oxygen, okay, and the water, and the H plus passes from anode to the cathode, and here at HAR it produces the hydrogen. Okay, so the thing is the OER catalyst should be very highly active, and the reaction should be fast enough so that it will provide more hydrogen, H plus ion. Okay, and then the hydrogen can be easily produced. But the problem is this catalyst. So what we are doing in our before that, if you compare the price of the iron with the iridium, you can see that iron, yes, the abundance of abundant material is only $72 per kg, whereas the iridium is 54,000 per kg. This is about the oxygen. Similarly, for the HR, hydrogen evolution reaction, is platinum is very effective, very good material, but the problem is expensive. So we are searching on the earth abundant material, and not just replacing the platinum, but we are trying to go through both this reaction, anode as well as cathode, the hydrogen evolution as well as oxygen, using a single catalyst. We call them as a bifunctional catalyst. So can this a single material can split the water into the oxygen and hydrogen? So the cost effectiveness will be greatly reduced. Okay. So what we are doing is we are working on the MXN material, the two-dimensional material, and these are the carbide and nitride two-dimensional materials. Here I have the examples, the thin film-like material. We call them as the 2D material. One of the famous and well-established material is the graphite. Okay, so the MXN are carbide and nitride transition metal, and these are the very fast-growing material in last 10 years. It was discovered very recently in 2011 in a tractor innovative by Professor Yuri Gorgosky, and till now more than 80 MXN materials have been theoretically predicted. Okay, but only very limited MXN materials have been synthesized. And my group here in Pandit Dindayal Energy University is trying to synthesize more different types of MXN. So how do we do this? We use mostly the MX space, where M is the transition metal like indium, titanium, A is the aluminum, okay, and the X is the carbide and nitride. So if you look at the history from 2011 to 2021, mostly if you go to the synthesis or the development of this material, you will see mostly the hydrogen fluoride, the very highly toxic or not only dangerous materials is being used to remove the aluminum, the A material. When you remove the A material from the max phase, you will get a single layer or layer type or occurrence like MXN material, 2D materials. Okay, so Yeah, for example, if you have titanium carbide, if you remove that aluminum by HF, you get the seeds like a mason structure. So this is what this material. But the main focus is not just about the application of this material, but also to develop the non-HF based method. Okay, so that we can remove that HF from the synthesis route. Why the MXN are good? They have wide application. Each and every field similar to the graphene. The MXN are hydrophilic, thermal stability, high electrical conductivity, and they can host many different materials from that. Dispersible in water, in aqueous material, large electrochemical active surface area, and structural variability. You can easily functionalize the surface. Okay, so these are the MX material. For example, titanium carbide. If you remove the aluminum from there, you get this kind of layer structure of MX. Okay, so what we did it, we instead of using HF, we used many different non-HF routes, and our group have synthesized material. Okay, and we are working on that to use this material for the hydrogen production, for the electrochemical water splitting and oxygen evolution reaction. So I'll give you one example. So this is the setup here at electrochemical setup where we are working on the hydrogen production. And using this material, if you can see the video, I will show you. See, we were able to produce the hydrogen. Now, the next challenging study we are going is how to improve that hydrogen production, and not just improve the hydrogen production, but also we are trying to develop the materials where we can store this hydrogen gas, and that can be used for the application. For example, the fuel cells. Okay, so this is what the present work we am doing. Beside the synthesis of carbon, the abundant hollow materials, transition metal oxide, sulfide, and phosphides, we are also working on the MXZ material for the electrochemical water splitting. Okay, so at the end, I think I'm okay. Almost 1 hour. This is my group, very small group, because I joined just last year here. In fact, I came to India last year, just before the COVID situation, and still my group is under developing. The students who are working is Jenny, the master student, Monica, PhD student, Ranjit, PhD student, Riddhi, but she's working on the environmental issues now, the water, wastewater treatment, on all those things. He's working on the water splitting, and she's working on the supercapacitor. So if I would like to, if any students are interested to join our group, you can mail me, call me, or go to our homepage to see the recent work and the projects we are doing. Okay, and finally, acknowledge to the university, school, and my national collaborators at Pune University, CSIR Joras, Pune University, Jain University, and the groups I'm working at international level, Professor Lee from Korea, Professor Dr. Pan from Canada, Professor Yu from Korea, and where I did my fuel cell work before joining PDP next month. Okay, and I would like to welcome all you to Gandhinagar, capital of Gujarat, the university, very green campus, situated in the Gandhinagar, just 25 kilometers from Ahmedabad. Okay, thank you.
Okay. Sir, very much thankful to you for your very good lecture. And if the participants, they have any query, questions, they can ask now to sir.
Yes.
Hello, sir. Myself, Dr. Sanjay Bhagat. So, as many people are working on producing of carbon for different material, what is the exact property we should check?
Okay, see, the properties of carbon, first is the surface area, second the conductivity.
As far as costing is concerned, sir, as far as costing is concerned.
Sorry, I did not get.
As far as costing is concerned, because there are many biomasses by which nowadays it is being produced, but property and costing, when we compare, we don't get proper results. That is what I was interested.
Costing is means, see, why the people have started from, like, I give you the example, there are synthesis of carbon is multi-step methods. The cost is mostly comes because of the multiple steps. You synthesize the silica, you need a template, then you need to different carbon sources and go through the various process and remove that silica material. So the cost mostly is there. The aim is to have a low cost and a simple route for the synthesis of carbon material. Then only you can do. But if you go to the biomass material, now the biomass or the most of the waste material, you get it, you can collect it easily. Okay, but the problem is drying. Okay, the second thing is, once you, for example, if you heat any waste to the 600, 700 degrees centigrade, it does not produce a very good quality of carbon material. There are many waste out there in the carbon material. That also you have to separate out. Okay, and not just that, but to increase the surface area, the pore size, you need a better quality of the carbon material. You have to go for various activation steps. I mentioned in the, for example, the KOH activation. People are using the KOH and carbon, and they mix it and heat it again. Again, they are using the second step. So try to develop a method where you can synthesize the carbon in a single step. Okay, so this is how you can decrease the cost of the carbon material.
Thank you, sir.
Hello, anybody having any other question? Okay, sir, I am having one question.
Yes, yes.
As far as this project is concerned, some of the part related to the production of hydrogen, and hydrogen having very explosive and other safety issues. So just how to overcome that safety issue?
Yes, that's what I mentioned in that. The storage is always issue of the hydrogen. But if you can correct me if I'm wrong, but to storage in hydrogen as it is not that explosive. Okay, until and unless it come contact with the substance. Okay, so that won't be explosive to store.
Okay. So any other, what we can say, some automatic control mechanism, whether it is available for the safety aspects of hydrogen, sir?
We are not working on this field, but what we are trying to develop the material where we can store the hydrogen.
Okay.
Sir, one question I am also having.
Yes.
Hello.
Yes.
Sir, about the membrane that is required in cathode and anode, we are applying one membrane. Whether this membrane will produce in India, production of that membrane in India, or we need to purchase from the outside only?
No. See, the work I did is mostly out of India, so I'm not that very well. But you can drop me mail or message. I can provide you information where we can get that in India.
Okay, sir. Thank you.
Definitely, many people are working in India. Many people, you will get it in India if you purchase.
Okay, sir. Thank you.
Okay. Sir, we are very much thankful to you for sparing your valuable time in giving us information about these various aspects. And we also request you to come to our college for visiting the.
Yes, surely. If I'm traveling to Jalgaon.
Yes, sir. You are
Definitely
invited for that.
Yeah.
And thank you very much for your wonderful new research, whatever you have done performing, that you are explaining to us.
Sir,
Yes.
if you are visiting your native, because naturally we are expecting you to supposed to have an interaction physically, so as to we can have an insight of this. Khare sir is looking after the particularly piloting project or undertaking the hydrogen
Production of hydrogen.
Production of hydrogen. Yeah. Whenever you are visiting,
Yes. We are also in some group together working here for that. My work is to production of hydrogen, and they are working in the hydrogen storage. So that would be a good interaction. I'll definitely let you know. I have your phone number and email ID.
Yeah.
So,
Thank you
I
very much,
just
sir.
now before Diwali I travel, so hopefully soon I will be coming again. Okay, thank you, Dr. Hussain and Dr. Diwali and all the organizing committee. Always pleasure to present at our native place. This is my first time I am presenting in. Always been presented in abroad or other places. Okay, thank you for inviting.
Thank you.
It was
Thank
great.
you.
Thank you.
Thank you, sir.